All right, we are in section 4 and 5. Perfect square trinomials. So there's nothing super special to this. It's factoring like we always have done for the most part. But in this section, you're going to get the same, quantity twice. So for example, number 1, you're given x squared plus 8x plus 16. Okay, you're going to get the same quantity twice in all of these. That's why they're called a perfect square. A perfect square is when something is multiplied by itself. You know it's going to be x and x. You know it's going to be plus and plus. They're saying for this section, these numbers are going to be the same. So it has to be 4 and 4. So they're just saying, hey, this is factoring like you've done before, but notice these ones are special. They're going to be the same thing twice, okay? So I want you to pause the video, do as much as you can on your own, and then come back and check with my answers. I'm just going to go through these. We're not learning anything new or different, just more practice. It has to be minus minus, and it's got to be 8, so this has to be 8. Yep, that works. It has to be y plus, it has to be y plus. Factors of 36, it's got to be 6 and 6. All right. This one's a little different. Well, we know it's plus and plus, so it's got to be plus and plus. We know 1 is the last term, so it has to be 1 and 1. 16, it's got to be the same thing, so it's got to be 4y and 4y. Some people would have said, well, why isn't it 2 and 8? Well, 2 and 8 aren't the same number. We want the same thing twice, okay? So it kind of cuts through and goes back up to the top corner of 9x squared minus 6x plus 1. See how the worksheet does that? It goes 1 through 5, jumps 6 through 10, and then goes back, okay? So same thing here. It's got to be the same thing twice. It's got to be 1 and 1. Break up 9, it's got to be the same number twice, 3x, 3x. You know it's 5x and 5x. It has to be plus plus. Factors of 1 are 1 and 1. Okay, so if at this point you're just watching me, really encourage you to pause the video and try these on your own. Okay, don't overthink this. This needs to be the same thing twice. You know it's going to be plus plus. 14 has to be the same, or 16 has to be the same thing twice. So you know it's going to be 4 times 4. 25, be the same thing twice. It has to be 5 and 5. Okay, don't overthink these. All you have to have is the same quantity twice. So you know that you need a plus and a plus. 9 has to be 3 and 3. 16 has to be 4 and 4. Same thing twice. You're just getting so much practice that this comes to you without even thinking about it. Seven x minus 1 minus 1. Has to be minus minus. Well, I just realized n squared, 2n and a 2n would be a 4n. Yeah, this doesn't work. This has to be per n. Yes, it works. Make sure you check to make sure it works. Okay, let's check. 6 times 6 is 36. 6 times 7 is 42, and 42 makes 84. 7 times 7 is 49. Yep. It's got to be 9. It's got to be 9. It's got to be minus. It's got to be minus. Okay. X and X. So 81. Negative 9 is negative 18. X squared. Yep. It's got to be the same thing. It's got to be minus minus. It's got to be 2 and 2. It's got to be 3y and 3y. 4, 6, 6, 12, 9. Yep. All right, that's it for factoring a perfect square trinomial. Now we're in part 5, which is special factoring. So you just got to kind of look at it and figure out which one is the methods have you done so far. So number 1, a squared minus 36. Go ahead and factor it if you think you can. I see this as two things being subtracted. So to me, it's the difference of two perfect squares. So the square root of a squared is a. The square root of 36 is 6. You're done. Number 2, it appears to be the same thing, the difference of two perfect squares. It's going to be 3x times 3x, but in between a plus 7 and a minus 7. Number 3, it's 169m squared minus 4u squared. 169, I believe that's 13 times 13 gives you 169. So it's going to be 13m and the 13m. All right, plus minus, square root of 4 is 2, and then we'd have to have a u and a u. Number 4, we're getting a little harder, but it's going to be the same thing. The difference of two perfect squares. So it would have been x and x, but also don't forget y and y now. Plus minus. Square root of 3 or 9 is 3, and if I split z in half, 4, it's going to be 2. Don't overthink it. What's the process? Don't overthink it. All right, number 5. Okay, we know y is going to be y and y. 25 is going to be 5 and 5. We know one's a plus, one's a minus. X squared is x and x. 1/4. If you cut it, it's going to be 1/2 and 1/2. That was a challenge. Number 6, 1/9 x squared minus 16. It's going to be 1/3 and 1/3 plus 4 minus 4. Number 7, 64 minus 8 to the 4th b to the 4th. 8 plus 8 to the 4th. Well, wait, we can't do the 4th. We got to cut it in half. That's the square root. Eight. This needs to be the difference of two perfect squares because there's two things being subtracted. I know 10's a perfect, or 100's a perfect square. If I slice that 6 in half, it's going to be y cubed, y cubed. 4/9. Well, 25, 36, 9, and 4 are all perfect squares. So it's going to be 2/3 and 2/3 because you take the square root of 4 and you take the square root of 9. xy plus minus 5, 6z, 5, 6z. 10 y to the 8th minus 81, y to the 4th, y to the 4th. One and a 1. You know it has to be minus minus. 4 and 4, u and u. So now we're going back to the same, it's a perfect square trinomial. So now they're starting with those. So 12, there's a trinomial again. Trinomial because there's 3 terms. So it's going to be the same thing, probably the same thing twice. You know, it's got to be A and B and B. You have 3 terms with a plus in the back. It's got to be plus plus. 3 and 3 make a 6. Yep. It's got to be x, it's got to be x, it's a plus, it's got to be a y and a y. X squared, xy is 2xy and a y squared. It's going to be 2x and 2x, and it's going to be a 3y and a 3y. Okay, then 15, it's going to be 100h squared plus 20h plus 1. It's going to be a 10h and a 10h. And it's plus plus, and it has to be 1, 1. Number 16, we have a trinomial. Well, it's probably going to be the same thing twice, so it's got to be 3 and a 3, because this is what we've learned so far. It has to be minus minus and a 4 and a 4. So 9, 12, 12, 24, 16. Yep. So this is just a review of what you've done in the past 2 sections, the difference of 2 perfect squares and a perfect square trinomial. Oh, here's another one. There's a GCF. Take it out. So you're left with a squared plus 2a plus 1. So you can do a, and it's plus plus, and it's got to be 1, 1. $18 is 5c plus 20, c squared plus 20, c cubed. You can take out a 5c from everything, and you'll get 1, 4c plus 4c squared. When you do that, I get 1 and 1 plus and plus, and try 2c and 2c. 1, 2c, 2c, 4c. Yep, it works. Number 19, it's a doozy, but it's something squared minus something squared, so it's a difference of 2 perfect squares. So what it really is this quantity and this quantity plus this quantity minus this quantity. So you could leave it like that, or you could simplify it. And lastly, same thing again. We see a GCF here. That's not really working. I want to simplify this. Do I expect you to be able to do this? No, but some of you could use a challenge in here. So I distributed this 10 to get this. I know when something's squared, it's something times itself. I'm going to FOIL it. That was 35. I know here this is going to be x squared minus 2x plus 1 minus 10x plus 35. I know that this is x squared minus 12x plus 36. So that's what this boils down to. Can we factor this? X and an x. It's got to be a minus and a minus, and 6 and 6. Yeah, it gives you 12 and 36. Okay, and that was the last one, and you're done with this. I'd wait till the whole sheet is done before you submit.